Hi, hello everyone. So last time we left off with our projection view, and then I mentioned that we're going to create this kind of cube, and that we're going to need to resolve, as you see, as it is spinning, it kind of looks weird, and that's because of the depth testing. So we're going to do that in this video, and for that you're just going to need this create cube geometry in geometry builder class, and you can find it on GitHub. I'm going to leave a link in the description of the video below. So it's part 7 or 8 by now, I think 8. So you can just check geometry builder method, and then in our coordinator you can call it here. When we're creating geometry, you can just call create cube geometry instead create quad geometry. So what's depth testing? So we're going to do that this time. So what's depth testing and how are we going to perform it? Well, depth testing is just basically checking let's forget about this. So we just kind of want to check if our z is less than some, let's call it z previous, right? And let's call this z coordinate. So whenever these values here, like these vertices, which are now rotating, but whenever they're drawn, we're just going to check them against the old value. And we're always going to clear out the buffer to 1, right? And then we have some z, let's say 0.5 here. And if our z is less than 1, we're going to write depth to depth buffer. And depth buffer is just going to be our texture. So if our z on some pixel, let's say this pixel or this pixel, it doesn't matter, right? If our z is less than 1, for now, then we write z, right? And if our z, which we're now going to call z coordinate, is, let's say, less, if our next z, let's call z next, is less than z coordinate, we're going to write it to buffer. If it's not, we're not going to write it. So it just kind of checks, all right, if this new z value is less than previous one, then we can write it. So how are we going to do that? Well, we're just going to need to create a texture, which is going to be our depth texture. And you're going to see how it works at the end of the video when we start a bit of debugging. So for depth texture, it's not that hard. We can just say here, so we're going to need something called depth. Depth stencil state. We're going to cover maybe stencil in next videos. I'm not sure. The stencil kind of can be used to hide some parts of the image or for some advanced algorithms. It's not important in this video, so we're not going to worry about stencil state, but we do need depth state, and they often come together. So we're going to have depth texture. So it's of type MTL texture. We're just going to say no, and then we can say it here, figure depth state. So we're just going to do usual stuff, create depth descriptor. So depth stencil descriptor. So we need our compare function. And what do we want to do? We have equal, greater, greater, equal. So usually you want less or less equal, right? So if our next z value is less than the current one, just write to buffer, otherwise ignore it. So is depth quite enabled? We just need to enable it, and then we can create depth state. So we're just going to say device, make depth state descriptor is our depth descriptor. Simple. So we're going to need the depth texture. So depth values are written actually to a texture, and the size of our texture is just going to be the size of our screen for now. So until texture descriptor. So we can say pixel format, and I'm just going to use depth32 float. So usually if you use stencil buffer, you might want to use some other format to leave some pixels, or some colors in the pixels for stencil test, but here don't worry about it. So we had our constants, and then we had game width, and then height. So we just need to cast to integer because this is in constants, it's float. And the texture descriptor, usage, and the target. It's used for rendering as well. We're rendering our depth values and depth texture. So actually we just need now to create depth texture device. Oh, my bad. So our depth texture descriptor. We're almost done here. So our unlit render pipeline, we're going to go there, and here render descriptor, we just need to set up the same pixel format. So we're going to say depth attachment pixel format is dot. So we use depth 32 float. Right, back to our coordinator. So here we just have to make use of that depth. But first let's just configure it. Configure depth. So let's say our render path descriptor, depth attachment. So we're going to clear it to 1. So our texture is going to be full white. Why? Because it's 1. And whenever we have some value, that z is going to be less than 1, so it's going to appear as black in depth texture. And you're going to see how it works just right now. Let's just finish it. So we just have to paste the texture, depth texture, and then we have to set that state that we had. So set depth. Let's say our render path encoder. Dot set depth stencil state. And let's try to actually run this. Okay. As you can see, now there are no artifacts here. So yeah, it already works, which is perfect. So let's try and see how that depth texture looks like. So if I build everything and I try to capture screen, this is a bit weird. It's going wild for some reason. Okay, got it. I'll have to check that, why is it going wild. It's probably something to do with the bug points. But as you can see here, if I zoom in, so we have our render target, right? So so this is where we draw our colors, but this is depth attachment, right? So we cleared it to 1, as you can see here. I cannot zoom anymore, but we cleared it to 1, so these colors here are white, and whenever we write, our z is less than 1, so it might appear black, right? And you're going to see that it has some values here. So, and that's how depth texture is usually going to look like, right? You're going to have bright regions, and then you're going to have black regions as well, or vice versa, depending on how do you set it up. Okay. So just for those of you who don't know, you actually have a really nice debugger here, and I haven't touched on debugger too much, but you can actually capture a frame here for the metal, so you can inspect well, basically your render path. All right, we're almost done here. So just to confirm that everything works as it should, so I'm just going to have unlit pipeline 2, and it's just going to be actually same as this one. So let's create it. So I just want to create 2 objects that are going to draw one over the other one, so just that we see that our depth testing works as expected. Right, so we need to set here as well second texture, so we could reuse this one, but yeah, I don't care. We're going to actually get rid of this unlit pipeline. to next time and draw it a bit differently. But for now we're good. So I just want to copy this kind of here. I'm going to say 2 here, 2 here. I don't care about this angle, and I'm just going to offset it a bit. So if I start that now, maybe I offset it a bit too much for an offset. Let's go with 0.5, 0.5. And as you can see, as this kind of rotates inward, it kind of works as expected, right? So we have our two intersecting objects, which fair enough, we don't check for the collisions, neither we will in this video series, maybe in some future ones. But the important part is you can see the depth values seem okay. So I just wanted to check that. And the next time, what we're going to cover is a bit more optimized drawing. So right now we had to create a second pipeline to actually draw the second object. So next time we're going to do some instanced rendering, but that's for next time. So hopefully you enjoyed this video. It was a bit shorter, but we did what I wanted to do. And if you liked it, please like, subscribe, and until next time.